AMD Steamroller Family 15 hours is a microarchitecture developed by AMD, which succeeded Piledriver in the beginning of 2014 as the third-generation Bulldozer-based microarchitecture. Steamroller APUs continue to use two core modules as their predecessors, while aiming at achieving greater levels of parallelism. Microarchitecture, Steamroller still features two core modules found in Bulldozer and Piledriver designs called clustered multithread, meaning that one module is equal to a dual-core processor. The focus of Steamroller is for greater parallelism. Improvements center on independent instruction decoders for each core within a module, 25% more of the maximum width dispatches per thread, better instruction schedulers, improved perceptron branch predictor, larger and smarter caches, up to 30% fewer instruction cache misses, branch misprediction rate reduced by 20%, dynamically resizable L2 cache, micro-operations queue, more internal register resources and improved memory controller. AMD estimated that these improvements will increase instructions per cycle up to 30% compared to the first-generation Bulldozer core while maintaining Piledriver's high clock rates with decreased power consumption. The final result was a 9% single-threaded IPC improvement, an 18% multi-threaded IPC improvement over Piledriver. Steamroller, the microarchitecture for CPUs, as well as graphics core next, the microarchitecture for GPUs, are paired together in certain product lines, and both support certain features specified in heterogeneous system architecture in hardware. History: in 2011, AMD announced a third-generation Bulldozer-based line of processors for 2013, with next-generation Bulldozer as the working title, using the 28 nanometers manufacturing process. On September 21, 2011, leaked AMD slides indicated that this third generation of Bulldozer core was codenamed Steamroller. In January 2014, K-Vari APUs became available. Processors APU lines equals. There are two main APU lines announced, K-Vari A-Series APU, desktop budget and mainstream markets. The Trinity/Rickland APU line is scheduled to be replaced on January 14, 2014 by the K-Vari APU line, as the third generation of A10, A8, A6 and A4 series for the desktop market. Currently known new model is a quad-core A10-7850K APU, with a 3.7 GHz core frequency and 4 MB L2 cache, incorporating a 720 MHz GPU with 512 stream processors and 856 GFLOPS of total processing power. These APUs have 2 to 4 enhanced Steamroller B cores, a GCN 1.1 Volcanic Islands integrated GPU, and 2 integrated DDR3 memory controllers. K-Vari APUs utilize the new FM2+ socket, thus they are not backwards compatible with the previous generation of FM2 motherboards. SIP blocks, Unified Video Decoder, Video Coding Engine, True Audio, AMD Infinity up to 4 monitors, 4K Ultra HD support, DisplayPort 1.2 support, socket FM2+- only, socket FM2 is not supported, support for PCIe 3.0, 2 or 4 CPU cores based on the Steamroller microarchitecture, 3 to 8 compute units based on the revised graphics core next microarchitecture. One compute unit consists of 64 unified shader processors, 4 texture mapping units, 1 render output unit, AMD heterogeneous system architecture 2.0, dual-channel DDR3 memory controller, integrated custom ARM Cortex-A5 coprocessor with Trust Zone security extensions. Select models support AMD hybrid graphics by using a Radeon R7 or a 7250 discrete graphics card. Berlin APU, enterprise and server markets. The Berlin APU will be similar to K-Vari, featuring 4 Steamroller cores, up to 512 stream processors, and support for ECC memory. FX lines equals. In November 2013, AMD confirmed it will not update the FX series in 2014, neither its current socket AM3 Plus version, nor will it receive a Steamroller version with a new socket. An unconfirmed article, citing anonymous sources with knowledge of AMD's internal roadmap extending into 2015, also did not mention plans for a new FX processor. Server lines equals. AMD server roadmaps for 2014 show, Berlin APU, quad-core x86 Steamroller architecture for one processor compute and media clusters, focused on cloud and media streaming. Berlin CPU, quad-core x86 Steamroller architecture for 1P web and enterprise services clusters, focused on big data processing and HPC. Seattle CPU, 4/8 core ARC64 Cortex-A57 architecture for 1P web and enterprise services clusters low-end applications with power-saving options. Warsaw CPU, up to 16 core x86 Piledriver architecture for 2P/4P servers. No plans for Steamroller or Excavator architectures on high-end multiprocessor platforms. References